So now let's talk about normalization. Normalization is this idea that we should reduce redundancy in our database so that way we don't have any anomalies or anything else floating up where customer information was updated in one place but not the other. We should store the element only once and only in one place. It also enables processing efficiency. If I need to retrieve a small bit of information, I have one place to look and one place to go, and theoretically a smaller data set to churn through because it's much more consolidated. This is also the separation between logical and physical design. The logical design may have an entity such as customers, and customers may have lots of different attributes about them, say their industry and sector and their address and those kind of things. And how you physically design that in the database may differ from what the logical entity is. And I'll talk about what that means, and that especially plays in when we talk about data warehousing and how data warehousing basically is a physical representation of the logical model. There are also different levels. I'm just going to mention this. I'm not going to go into the details of each of them. But if you want to get deep into this, or if you're becoming a SQL DBA, for example, or a data modeler, you're going to want to know about all the different levels of normalization. So the most common one for something to be considered normalized is 3NF, which stands for third normal form. So let's take a look at our example with our data set here and just keep working with this. So before we talked about tables and how they relate to each other with relationships, now we're going to talk about the columns and how we actually separate out the columns into new tables to normalize that data set and eliminate redundancy and facilitate processing efficiency. Here's all of the fields from our sales data set. This is the same one we've been working with since the earlier stages of this course. And what I'm going to do is going to actually parse these out and give you an idea of how you would normalize this. This is a common thing where a lot of companies or a lot of people will build their data set with just all the fields they want. And this is really good often for analysis. This is how you want things for analytics because it's easy. You just have to go to one place to answer all your questions. However, when you want to process the data, when you want to use a transactional system to insert and update information, you want to build an application on top of this, it's not ideal to have one table with everything in it. So you separate those things out. First, let's just gray out the fields that are kind of superfluous here, the row ID and the row count. We don't need those. Those are just added as a factor of our spreadsheet. Now let's look at the other data here, and let's take out our order information. So what I did there is I just simply parsed out all the pieces that basically you'd say are an order themselves. It is its own unit. Now we'll take customer information, which fits neatly right there, and it has all the bits about a customer themselves. Then we separately have product information. And lastly, we have our staff or our employee information. So each of these four buckets kind of represent these entities that are related into what you would call a sale. And so we may have in our database model the concept of a sale, and these may be all the different physical representations of that in separate tables. So we'd give each one of these its own name, essentially. And then we would define relationships, which actually defines how our business runs. Now, you could further normalize this by breaking out things like city, zip code, state, and region, because those may apply to customers as well as employees, as well as department stores, as well as many other things. So it may make sense to eliminate that from this and have a separate table for either each one of those elements or such as an address table.